Next one is Lloyd talking about Flutter Rust Bridge.
Hey everyone, I'm Lloyd. I'll skip the personal intros and stuff and just get straight into it. I'm a cryptographer by background, so that's important. I've just been doing UI successfully for the first time in my life. I've been obviously called, like probably many of you, been called on to make a UI for something at some point. Despite it not being up your alley, and it never really worked out well. But this recent call has been working quite well. So I've been using Flutter Rust Bridge. I'm going to tell you everything I wished that I knew from 6 months ago. And so it's how do you write a phone app with as little non-Rust code as possible, while still being able to Google why that fucking button isn't displaying correctly, right? Why is this a strong combination? So Flutter is a Dart app framework by Google. Dart is a type-safe language like Rust, but is very object-oriented, not like Rust. I don't know why Dart exactly exists. It doesn't have a good reason to exist, in my opinion, but it did, and Google's behind it, so the tooling is pretty good around the language. It has like some null safety features, which is nice to have. It just means you can do unwraps really, really easily, which is not what I had in mind when I'm thinking about null safety, but you have a little exclamation mark to do an unwrap. You have a question mark, which means unwrap or, and the compiler kind of knows when you haven't, you can tell it that this is an option kind of thing very quickly by putting a question mark at the end of the type. Okay, so it's mature. Flutter Rust Bridge is this way of essentially generating FFI bindings for Rust projects into Dart and Flutter very, very easily. It's mature and actively developed. Allows you to, while you're developing hot reload UI stuff without having to like recompile Rust things. Just rewriting some Dart makes the button you're trying to get to work correctly redo itself in less than a second. So that's pretty good. They speak to each other well because you can model the sum types like enums in Rust in Dart, and that's no, I got to go down. Okay, yep. So you can write your application model and business logic in Rust, and write your UI in a type-safe, garbage-collected language. Deploy on any platform, have hot reloading. So it's kind of like the best of both worlds that you can have at the moment, it seems like. I'm not an expert on all the different ways of doing this, but it's pretty good. You've got your type-safe Rust for your business logic and your data model, and then for the bits and pieces of buttons and making things whiz around the screen, you've got this garbage-collected language where you don't have to worry about the compiler getting angry at you. So then really like the key feature that you should remember from this talk is that you can actually have these sum types from Rust and they actually translate into Dart, and the thing will do that for you. So this is like an enum maybe, obviously it's like an option, except that it uses like a field type enum variant for the sum bit. And you can see in Dart you can do a switch statement which works like a match statement, and it just works like that. It's very, very nice. You don't have that, I think, in other languages. It's like quite some heavy lifting in Dart to get that. It doesn't do it natively, but there's some wizards who've made a library called Freeze to do that. And yeah, just don't use the parenthetical enums because they don't work well in Dart. They don't have the .0 feature that you can do in Rust. So use the ones with named fields. This is what one looks like from my app. So this is just what I'm doing cryptography with generating keys and stuff between different devices. And so I've got this keygen stream, which is emitting these kind of events, and there are enum different kind of events. And what I want to do is just, you can see, look at the bottom one. I want to find a particular event that's like a finished key event, right? And then just get the key ID out of it and return it, and that's a future. Okay, so that's a stream, using a find map on a stream to get a future of that potentially discovered key ID, and the top bit is Dart. Okay, so Dart is not quite as good, right? But it's fairly compact and efficient, right? I mean, it's kind of messy because it's not what they were thinking about when they designed the language, and all these combinators are not as well thought out. It's as the Rust, but you get the same effect, right? It's the same way of approaching the problem. And so you can approach the problems in Dart after you've learned the tricks in the same way you would approach them in Rust. So how do you write an app with as little Dart as possible? You can imagine this Flutter Rust bridge, or with FFI things in general. You're thinking, I'll do my app with the proper UI framework, but then I'll just have a few functions that need to be very efficient written in Rust. And that's not what I'm doing here, okay? I'm doing, let's do the whole thing in Rust basically, except for the actual buttons and styling bit of it, right? So how do you do that? This thing called the block pattern. I don't know what really that is, but it's very popular amongst people who talk about React and stuff. But basically, this is my understanding of it. You do your business logic in one area, and in this case, it's going to be Rust, and it consumes events. So it consumes stuff from I/O, user actions, right? So it's consuming all these events, this business logic, and then it's emitting states. Okay, a stream of states is coming out of that thing, and the states are going to your UI elements, to the Dart widgets, and they're consuming that state and rebuilding themselves based on the states that are being emitted. And so, yeah, we're going to do the business logic all in Rust, and anything that happens is going to be, mostly told to Rust, and it's going to emit states up to Dart. That's the way you should approach this. Okay, so. When the trick is that I've never done this kind of UI stuff before, but you want to actually, when you're emitting these streams, we're emitting the whole state. We're not just emitting like something that has happened. We're emitting the whole state up to the thing so the widget can rebuild itself. So how do we structure events? This is one that's just from my library here. So we've got this device list update. It's going to update something has changed. So we include the whole state in there of the whole device list, and we do conclude some of the changes, like why are we emitting this state? Because some things have changed. We've got the list of changes. We've got both. We've got the changes. We've got the state, and then that's basically that's what you're doing. One thing to note down the bottom here is I've got this device ID. That's actually from another library. That's a pure Rust library. It has nothing to do, doesn't know anything about Dart, but I'm doing this FRB mirroring of it. So the Flutter Rust bridge will actually just take this definition, this underscore device ID here, and I'm just telling the code gen what that type looks like. Okay, and it has to be true. I could be lying, and then there'll be a compiler error. But if I get it right, and device ID is actually a 33-byte array, that will work seamlessly, and I'll be able to have that type in Dart, okay, from a totally different library. It's really nice. It saves a lot of time. You don't have to be wrapping things and new type structs all the time. It's be able to translate things even from other libraries, as long as they're in a normative form. They're vex or there's standard primitives. Hash maps won't work. B-tree maps unfortunately don't work. But vectors and other primitives all composed together will just go straight up to Dart with no wrapping needed. And so I make a stream here. And so there's this magic thing, like someone wants to know about device events. So I subscribe to them, and this stream, if I put that in as a parameter to the function, it's magic. And the Flutter Rust bridge would just look at that, this guy's making a kind of stream thing, and will you will not actually pass that argument in on the Dart side. It'll be elided and removed. It's just telling the framework or the code gen that it wants. This is a stream generating function. And so then, I'll just set it in a lazy static here. In this case, because it's actually like a global thing, you could, of course, not do that and save it in some local data store, however you want to do it. But here is just a global thing. And then on the Dart side, this is how I tap into that. So I just call that sub-device events. I'm subscribing to device heads, and I add the magical as broadcast stream. That means that any part of my application can just get that global event stream at any time, and it just gets its own copy of it, right? So there's multiple consumers. That's what the as broadcast stream does. Otherwise, they'd only be allowed to have a single consumer. And so then, I've got some button, and this button needs to know about this device list. Okay, just needs to know about it because it's not even going to display the device list, but needs to know how many things are connected, how many devices there are, just to have the button work, or like gray itself out if there isn't enough devices, something like that. So we could just tap into the device list. We use this stream builder. That's the most crucial thing. Okay, stream builder. This widget will you subscribe to the stream, clean up the stream once it's finished, and rebuild the thing inside the build callback function thingy anytime there's an update to the stream. You also pass in initial data because you don't really want your widget to have to wait for some event to happen for it to appear. So you pass in the initial state. You pass that in first, and so I just make, the question is how do you get that initial data, right? So you imagine you would just have this function like get device list state. Problem is that by default, everything in Flutter Rust Bridge is async. So every function you call, because it's by default running on a separate thread, is going to be async. So it's going to return a future, but sometimes you don't want that. You opt out of that with sync return. Okay? So sync return lets you have a synchronous return. It'll run the call in the main Dart thread, which is very dangerous if you plan on locking anything, because your application will be frozen. But if you're careful about that, we can actually do a synchronous call straight with no futures or anything to get in our way during the build function of these widgets. Which you're not allowed to have asynchronous stuff happening in those build functions. You just got to build, display the button, come what may, basically. There are probably other ways of doing this, but this has served me quite well. But unfortunately, we can't use Stream Builder all the time. If only, because it works very, very effectively. It means you don't have to manage any state. You're just getting these states that are coming out of the stream and doing stuff at that moment. And that's a very efficient way of working. But stuff like animating a lists that like have things fly in and fly out and remove at certain points, they can't figure out what to do just by looking at a new state, right? I mean, it has an old state, has a new state, but doesn't know how to figure out what has actually happened between those states. So for that, you do have to communicate changes to your underlying model. And so you have to tell the list where it's being removed and stuff. And this is a lot of code you probably cannot read, but that's how much more involved that is. You've got to manually open the stream yourself with the subscription. You've got to manually clean up the stream in the dispose. But the really nice thing is, like, once again, here we're in this for each change I get in each thing the stream emits. I'm doing a switch statement and a case statement, and it's just like a Rust match statement. So there's that's just an enum defined in API.rs, which is what the Flutter Rust Bridge is using to do code gen, and that's how easy it is to react to those things. And I'm inserting items when things are added, removing them when they're removed, and that will make the list, come and go. It's pretty easy. It's not too bad. So basically, here's the summary. This is what you should try and take away. If you ever plan on using this thing, try to use state-based updating. So you're emitting states from the main business logic using Stream Builder. The items in the streams are the full state of the thing. Although this sounds like scary, like maybe you have a vector of thousands of things or millions of things, you should consider why you're telling your phone app millions of things, right? So first of all, does the phone really need to know about a million things? But also, if it does, or for some reason, there are ways to not have that do memory copying. I've left that out of this talk, but you can do it without memory copying and just still emit the full Rust struct into Dart via magic and just have pointers essentially being shared. Get the initial data from a sync return function. And then you have event-based dating, event-based stuff, subscribe to the event in an init state, which is where the widget sets up the stateful widget sets up its own state. And each event is defined as a Rust enum, gets translated into Dart, and you match on the case. You do a match statement to figure out what has actually happened and react to it within your widget. Usually, so in your design, Rust doesn't really care about which one of these things you're doing. You just do both. Emit the full state, emit the changes, and you just consume it where you want to. And I consume that device list thing in a bunch of different ways, in different widgets. And sometimes I'm caring about the event, sometimes I just care about the state. You don't need to know about that on the Rust side, right? It's when you're designing it. There are some more problems with this. So Dart can call Rust, but not the other way around, okay? So I cannot somehow call Dart functions in Rust. It's a slight limitation. So, for example, what if in the Rust side of things you need to do an HTTP request? you want to respect the phone's HTTP proxy settings, for example. So you want to use the native HTTP client that the operating system is giving you. In my case, we want to use the phone's USB port. Okay, and we need to talk directly to that. We cannot talk to that through Rust. And by opening devices, actually you need to ask the user's permission whether you can speak to the USB port. So you have to do that through Android, for example. So how can you do this? I emitted streams of requests. That's the design that I eventually came up with. It's like on the Dart side, I'm consuming these are the things that the Rust wants to know as it's running in its own thread. And here are some events. So once again, we've got an enum, and these are requests to open stuff. And it's like, I want to open, write, read, how many bytes are there to read from the port? And I will create this port open thingy. And it has the parameters to this function that I essentially want to call on the Dart side. And it's got a one shot to send it back, right? Send the result back to me. It's an opaque, so you see Rust opaque. So this is, I can put any Rust thing into a Dart thing now. The Dart thing has it. I can even call this satisfy method on it. So once I've satisfied, when I want to satisfy the request, it's either, in the case is port opening, there's nothing to satisfy, I just said thumbs up, it's open, or it could be an error. Which we take that's called from Dart, right? This satisfy thing is called from Dart. We push it into the channel, and that satisfies the request, and that's how we can call Dart things from Rust. So it's quite a bit of a mess, but it does work extremely reliably. So this is like what the Rust thing would call when it wants to open up a port. It would, create this channel, emit the event, put the sender inside the event, in a Rust opaque, and then wait for the response. So that's a blocking request to Dart, and eventually Dart will respond to that because it's consuming a stream of events. This is pretty much the last thing I think about you probably want to know. Using Rust types in Dart is pretty great, but it's sometimes not so great, especially with respect to equality. It's always referential in Dart for some reason, but sometimes it isn't. Like for strings, it's not. You have to. It's kind of like you implement your own equality there over there in Dart. Not sure how to do it for my own types that are generated by the thing. So even hash set and hash map just won't work for your things in Dart, which is another reason to do most of the things in Rust. But sometimes you do need to have some set of things, like a hash set of things over in Dart. When user is selecting buttons, you want to keep a set of the things that are selected. And so you have to do custom equality. So we've done this, FRB mirror thing, which is mirroring the type. But over in Dart, I need to make these this is my special hash set for device IDs that has does list equals, so it checks the quality of the bytes inside, not just like the references. And just does hashing of field 0. Field 0 is .0 equivalent in Rust, right? Tips for setup. Start from this template project. Look at the just file to see what's actually happening, what commands actually this work that is doing. It probably won't work first time on all platforms. Putting inside a workspace, Rust workspace, if you want your native sort of FFI bridge code, the API.rs, which generates all the FFI code. If you want that in a workspace, it won't work immediately. You need to change CMake files and things, and it's hard to figure out. Make sure you're using the same version of Flutter Rust Bridge in all places, and you will suffer for a few days. And then probably a few weeks as you learn Dart and learn its edge cases, and then after that, you will be a very productive UI developer. And read the manual. Once you've gotten to that stage, a mistake I did was I had to figure out everything myself to get it installed. I assumed these guys had nothing useful to say in the manual because they couldn't figure out how to tell me to make the project template work in the first place. But actually, the manual is very good. Once you actually get it working, read that manual and learn all the tricks before you start writing the code. Questions?
Thank you. It's actually not so much a question, but I had an epiphany when I sat there and you were talking about this block pattern, and I realized that without knowing the pattern, we've done the exact same thing in a web application where we use this, what seems like age-old technology, which is server-side events, server-sent events. And we just had like basically one stream to the backend and just take state, feed it into React, have it display, and any button click whatsoever would just send a post request. Backend takes it, makes some changes, and sends back an event, and it actually worked marvelously. So I'm not surprised that it works very well here as well.
Excellent comment. Yes, sending over all the data, it makes things much easier for the client. If you can do, and in this case, the client, and there's no client and server, so you're just in the phone, and that's native Rust bit and Dart bit, just send all the shit you need and just build it like that. It's much easier.
We did a slightly different approach using this, where we kind of treated Dart more like Dart and Rust as system boundaries. So you have kind of like the whole model built up on the other side, kind of more encapsulated whatnot. You could actually switch out the whole backend, not use Rust. So I find this very interesting because we kind of wanted to go there at some point, but it became quite cumbersome because you constantly have to generate code. Like, I mean, you do your whole model in Rust, but then you kind of need the Dart code as well. So you constantly have to generate code, which was kind of really cumbersome when working in the UI. Do you feel that? Not? I don't know.
Yeah, so I also originally modeled quite a lot of things in Dart. And I made, that's how I learned some Dart. And I made a class which is just modeling the data. And then I just said, actually, why am I doing this at all? It doesn't make any sense. I'm going to move this all to Rust. And then it works quite well. Okay, so that's the reason why I do it like that. Now, you have to update the bindings so that Dart can use them. There are two ways. I mean, you can manually run the command anytime you change API.rs. And yes, I do sometimes things happen and I have to run that fucking command again. But you can, if you want to, I think you can just put it in build.rs. Right? So if you want to run the command anytime you change anything and just do like cargo check or whatever, you can actually do it like that. And it'll just naturally do it for you. So that's a nice way I've seen people do that.
How complex is your user interface? Maybe in terms of like, I don't know, how many widgets do you have? How big do they get? How much are they composed and such kind of things? Just to get an idea, because I think for a simple project it's great. But once this grows, I'm not 100% convinced, to be honest.
I don't see any scaling issues with respect to the project. In fact, there would be scaling issues if more things were in Dart. That's the way I feel. I feel like this is actually sidesteps the whole scaling issue, and I can just scale the project as I normally scale Rust projects. The widgets, yeah, I mean, I'm not like I've been doing this for a few months now, and a lot of that has been focused on the actual business logic, which is the core value thing, which is in the Rust side. Widgets, I mean, yeah, there's 7. I don't know how many widgets there are. Thank you. All right, cheers, guys. Thank you.